The travel to Peru shows a different reality to those evaluated so far, both in India and Spain. This South American country has ideal climatic characteristics to study the pattern of production of bioethanol from sugarcane and compare it with sweet sorghum. Sugarcane and corn are the choice raw materials for bioethanol production worldwide. In the case of sugarcane, Brazil has been the world leader in this production when in the 70s opted for a clear and effective alternative to oil. Today, the passion for bioethanol as an economic and social engine has spread to other cane-producing countries in Asia, such as India, China, or Indonesia, and Latin America with countries like Colombia, Ecuador, Costa Rica, and Peru. In the case of Peru, has an additional advantage that adds value. In Peru, there are areas such as Paramonga, where the saffra or sugarcane harvesting period extends throughout the year. Staggering the crops and fields, fresh cane is achieved throughout the year, which allows making more profitable investments with smaller plants and maintaining large productions. Peru is a country predominantly sugarcane producer. This production has been the basis of an industrial sector of great importance. Cane production in Peru mixes tradition and modernity, interspersed mechanization and manual processes. Like the cane cutters who use traditional processing methods such as burning of the field prior to cutting, making work safer without compromising performance in the production of sugar. This is achieved because the stalk of sugarcane is not degraded by fire, just burning of the leaves that come with the same stalk. The subsequent transport of the stalks is made with heavy trucks, which ensures that the time from cutting to the processing the sugarcane in the production plant of bioethanol is reduced as much as possible. Sugarcane is one of the most important sectors in Peru and most of Latin America, being a world leader in bioethanol production. Agricultural investments made in Peru have improved varieties of sugarcane and production yield significantly. They are working very actively in the evaluation of the type of irrigation, fertilization or fertigation, framework of planting, etc. Thus, they have been able to assess different types of irrigation, searching more efficient, less water consumption, and increased production. Among the tested irrigation system in Peru, there are several options like gravity irrigation, channels, sprinkler irrigation, and drip irrigation. Each type of irrigation has led to modify the framework of planting while is maintaining a similar production per hectare. With this improved irrigation system, it has reduced water consumption significantly in a country where water is scarce, without neglecting high productivity of sugarcane per hectare with high levels of sugar, achieving and ensuring the agricultural sector, providing jobs and social development, and acting as an economic engine. Sugarcane harvested in the field is transferred to the processing plant by heavy trucks. Thus, a continuous and high flow of trucks is maintained in the sugar mills, necessary for continuous production in the production plant due to there is no previous storage in plants. Trucks and trailers used for this transport allow for unloading of the sugarcane by cranes and tapes in the receiving hopper, where the process of transforming sugarcane begins, passing through an initial high-capacity transporter and a sugarcane grinder until reaching the rolling mills. Currently, the production systems are controlled from a control room. In this control room, the evolutions of all variables influencing the production process are recorded. As has been seen in the past, the use of sugarcane as well as the use of sweet sorghum allows the incorporation of biomass boilers using bagasse as fuel and thus able to produce electricity and steam for the process. After downloading cane sugar, washing and shredding, it passes to the extraction phase on the rolling mills. In the extraction process are installed between 3 and 5 rolling mills online, which takes it to obtain a sugar extraction yields close to 95 to 97%. These mills have evolved and improved over time, changing the steam for electricity to make its operation. Although there are still some testimonials examples of these old steam mills used before increasing efficiency in power generation from sugarcane bagasse. The yields of sugar extraction are also achieved by using a small amount of leaching water that is added in the last mill. Considering that the juice obtained from the last rolling mill will be used to facilitate removal in the previous rolling mill and so on until the first of all. As a result, we get the sugar-rich juice and bagasse with 50% residual moisture used as fuel in boilers to generate steam and electricity required for the installation. The effort and work of the operators of these facilities are the basis for the great results that are getting. The complexity of the facilities requires holding a high level of operation and formation, ensuring the proper functioning of the entire facility. As a result of the extraction and clarification, they obtain a sugary juice that will be used for the subsequent production of bioethanol and sugar. Sugar has been the main product obtained in the cane-producing countries until the development of bioethanol demand, at which time it has started a coexistence and complementarity of both products, which has achieved an improvement and development in agronomic and industrial sectors. Sugar production industry remains a benchmark in these countries. Without the ethanol will pose a threat or a competition, but rather a complementary and supportive. The special situation that exists in Peru allows finding areas of high productivity of sugarcane per hectare and desert areas where water scarcity has led to the failure to develop crops efficiently. Until now, investment in irrigation, fertigation, pumping systems, and efficient water management have transformed a desert into arable land with production yields similar to the most fertile areas of the country. Where the investment is constant in all aspects of production, irrigation, harvesting, processing, and so on. By replacing traditional systems of harvesting and collection of cane, modern harvesters that increase efficiency in collection and transport, reducing the time required, the loss of sugar, and increasing the biomass available per hectare for energy production. This agricultural investment goes hand in hand industrial investment, which seek to apply the latest technology for bioethanol production. The result is the development of modern facilities for the production of bioethanol in the Piura region in southern Peru, where exist two large companies that have invested in bioethanol as a way of development. Maple and Caña Brava have transformed a semi-desert area in the major center of bioethanol production in Peru, where they has committed to implementing the best technologies in the processing of sugarcane and bioethanol production. As is the case of continuous diffuser to extract the sugar from sugarcane as an alternative to the traditionally rolling mills used in the industry. As the latest technology in distillation and dehydration of bioethanol. Bioethanol in Peru is beginning to move steadily towards an effective implementation and necessary. This results in the development of new legislation that promotes the use of ethanol blended with gasoline by 7.8%. Although it is necessary to organize forums, meetings, and conferences where you can show the advantages of these measures. In these forums is where you resolve questions that arise ethanol consumers, users, and other actors in the value chain. Also, we provide a platform to present the work being done to improve the field of bioethanol production and consumption worldwide. As is the case of Sweethanol project, source and responsible for the development of this video, with which you want to put on the table the reality of the sector points for improvements and strengths, and that is the basis of generating new business model that uses sweet sorghum as raw material. That is the objective of the Sweethanol project, that sweet sorghum becomes an effective and profitable real alternative to bioethanol production in Europe, Asia, or Latin America, and that this raw material can coexist with existing raw materials and implemented, such as sugarcane and cereals, to improve the sector, improving sustainability and improve social benefits that would result cultivation.